So here we're looking at section 10.3, and our learning targets are first we're going to make two-way tables and figure out what those look like. Then using those two-way tables we're going to find relative and conditional relative frequencies, and then we're going to use those conditional relative frequencies to find some probabilities. So first let's look at what a two-way table is. So a two-way table is a frequency table that displays data that we've collected that belongs in more than one category. So here we surveyed freshmen and sophomores about whether they're attending a school concert. So a two-way table is one way to organize those results, because you'll see I have both freshmen and sophomores here, and attending or not attending. So each piece in this table is called a joint frequency. So each individual cell is a joint frequency. And then if I add up the rows or columns, those are called our marginal frequencies. Now these two are going to come in handy in a little bit, so it's good to just kind of see them laid out basics like this. So now here's our first example. In another survey similar to the one above, we surveyed 106 juniors and 114 seniors responded. So of those that responded, 42 juniors and 77 seniors planned on attending. So organize these in a two-way table, then find and interpret the marginal frequencies. So first thing I have to do is find each joint frequency. And remember, the joint frequency is each individual cell that's going to go into my two-way table. So I know that 42 of the 106 juniors are attending. I have to figure out how many juniors, so I subtract them, are not attending. And I do the same thing with seniors. I know 77 are attending, so I subtract that from my 114, and I find out that 37 are not attending. So now I can put each of those into its appropriate cell, right? So juniors that are attending, juniors that are not attending. So now once I have each of my joint frequencies, I can find my marginal frequencies. So I add up my total juniors, right, which I was also given in the problem, and my total seniors, and then I can find the total number of students that are attending and the total that are not attending, and from all of this I can find the total number of students that were surveyed. And a lot of that is information that I can find just in the problem that I'm given. So I know that 106 juniors responded. There were 114 seniors that responded. I know that 101 students are not attending, and then 119 students are attending, and there was a total of 220 students. And then if I want to find more data from that, I can look further into each individual piece. So in order to find the sums, I just add them all together. So the total in this column will be the same as the total from this row, because this last piece right here, the total number, is always going to be the same sum from these two parts. And that's how I can then analyze and find the total that were surveyed. So now here is your first monitoring progress. Go ahead and try this one and see what you get. So now we're dealing with some conditional frequencies, okay? So a joint relative frequency is the ratio of a frequency that is not in the row or total, so one of our joint frequencies, right, in the cells, to the total number of values or observations. So we're going to look at some examples that walk through these. But just know that the joint relative frequency is I take the joint frequency divided by the total. So then a marginal relative frequency is the sum of the joint relative frequencies in a row or column. So first I find all of my joint relative frequencies, so each individual cell divided by the total, and then I can add those to find my marginal relative frequency. And then a conditional relative frequency is a ratio of my joint relative frequency to my marginal relative frequency. Okay, so I can use either the rows or the columns when I'm finding this conditional relative frequency. So let's look at some examples to actually work through this. So we're going to be using the survey results from example 1 to make a two-way table that shows the joint and marginal relative frequencies. So first off, I always start with just the numbers, right? So in my original example, I had 42, 64, 77, and 37, and then I knew my total was 220. So to find my joint relative frequencies, I divide each individual cell number by that total, which was 220. So here I have 42 divided by 220, 77 divided by 220, and I just continue on. Then to find my marginal relative frequencies, I just add going across. So I'll add my 0.191 plus my 0.291, and that's my marginal relative frequency. And then I can also add these going down to find my totals down here as well. So what this really tells me, that 51.8% of the students in the survey are seniors. That's what this survey tells me. I also can get more information. So here my example, about 29.1% of the students in the survey are juniors and not attending. So this includes both pieces of the information. The marginal relative frequencies kind of just give me a little bit less information, but still very useful information. So now we're going to look at this next example. So use the survey results, we're using those same survey results, to make a two-way table that shows the conditional relative frequencies based on the row totals. So here when we're talking about conditional relative frequencies, we have to know if we're looking at rows or if we're looking at columns. So I start with what I had before. So I am dealing with my joint relative frequencies, right, which I found back in this example. So first I divide the number of people in each cell, right, so each joint frequency, divided by the total to find my joint relative frequency. So now I take that joint relative frequency and I divide it by the total that was in my row. And I use these totals, because I was told in my example that I'm basing this on my row totals, not my column. So I'm using the marginal relative frequency of each row to calculate the conditional relative frequencies. So I take the values that I found from before and I go ahead and I divide them. So this tells me this statement right here. So given that a student is a senior, the conditional relative frequency that he or she is not attending, right, because we're in the not attending, is 32.4%. So that's given that the person is a senior, the conditional relative frequency is that they would be attending the event is 67.6%. So now I can use this information to help us find some more probabilities and some data from that. So now here is your next monitoring progress. Try them, see what you get. So here's our next example. A satellite TV provider surveys customers in 3 cities. The survey asks whether they would recommend the TV provider to a friend. The results, which are given here as a joint relative frequency, right? That helps us know what exactly we're looking at. These are shown in the two-way table. So first I have to know that I'm looking at joint relative frequencies. So going back to how I find joint relative frequencies, right? I took the number of people that answered that specific thing divided by the total number of people in the survey. So that's how I found these numbers. So I want to find the probability that a randomly selected customer who's located in Glendale will recommend the provider. So I want to find the probability that they say yes and they're in Glendale. So I find the probability of Glendale and yes, right? So they've said yes and they're in Glendale, divided by the probability that they live in Glendale. So I can just add these two things together to find that total that would go down here, okay? And I am limiting it to Glendale because that's what I'm told in my problem. So I go ahead and I do my 0.29 divided by that column total, which I would just add these two together and I get approximately 0.853. So then I'm dealing with percentage, and so the probability that a customer who lives in Glendale will recommend that provider is about 85.3%. So now let's look at part B. What is the probability that a randomly selected customer who will not recommend the provider is located in Long Beach? So I know I'm looking at no for not recommending and specifically Long Beach. So now let's look at what I'm looking at. So I know I want no in Long Beach, but then I'm looking at everybody that said no because that's the group that I'm limiting it with in my problem. So that's where I add these together and I come up with my percentage, and it's approximately 33.3%. So now let's look at part C. Determine whether recommending the provider to a friend and living in Long Beach are independent events. So remember that I can compare things to determine if they're independent or dependent events. So here's my formula. The probability of B, which is the second thing, equals the probability of B and A. So then I'm comparing Long Beach, and then I'm comparing Long Beach and yes. So the probability that we're in Long Beach, right, is 30.32 and 0.04. That's my total of Long Beach. So then I can look at Long Beach and yes. So yes and Long Beach divided by the totals of my yeses, because we're looking at are they dependent or are they independent events. So I've got my 0.32 divided by my totals of my yeses, and I see that my percentages end up the same. Well, approximately the same, close enough. So since those two are approximately the same, yes, they are independent events. So here's your next monitoring progress. Try them, see what you get. So here's our last example. A jogger wants to burn a certain number of calories during his workout. He maps out 3 possible jogging routes. Before each workout, he randomly selects a route, then determines the number of calories he burns and whether he reaches his goal. The table shows his findings. Which route should he use? So first, I just want to take a minute and look at the data that I've collected. So I see that route A, I've reached my goal 11 times and not reached my goal 6. Route B, I also reached my goal 11 times and did not reach it 4. In route C, I reached my goal 12 times and did not reach it 6. So I want to first make a two-way table because I see different routes that I did, and then I have reaching goals and not reaching goals. So that's the first thing I do is I make my two-way table. And then I look at my joint and marginal relative frequencies, right? So again, I divide my number that reaches from route A that reached my goal by the total number of times I did the workout to get each of these. Then I just add going across my rows, and I add going down my columns for my total of 1. So there are a total of 50 observations in the table. And I know that if I add all of my data up here, I would get that I have a total of 50. So I can just divide my 11 here by 50, 11 by 50, that's where these two numbers are the same. Then I have 6 divided by 50, which gives me all of these numbers here. So I can continue doing that. So now I want to look at the conditional probabilities. So first I divide each joint relative frequency, right, these ones in the white, in the reaches goal, because I'm really concerned about do I reach my goal, by the column and my corresponding rows. So here let's look at what we're looking at here. So my reaching goal on route A. So I take the probability of route A in reaching my goal, divided by the total of route A, which is that 0.34, and I get 0.647. So now let's look at route B. How did we do on route B? We got a little bit higher of a number. And route C, again, I divide the reaching goal by my total. So now let's see what we end up with. So based on this sample, my probability is highest that I reached my goal on route B, so I should go ahead and use route B. And I know that because this number right here is higher than the other two. So I would go ahead and say that that would be my greatest advantage right there. So here's your last monitoring progress. Try this, and this is very similar to that last example that we looked at. So now let's look back at our learning targets. So first, we needed to make a two-way table. So just remember that our joint frequencies are the numbers that go in the cells, and then I can use that to find my relative frequencies. So first, putting my data into a two-way table. Then from there, finding the relative and conditional relative frequencies. And then that's where I'm just dividing by my total number of people or total number of data points, and then using that to help me find some more data. And then in that last example, we used conditional relative frequencies to find conditional probabilities. We determined which one would be best based on those frequencies and those probabilities. So now that we've done this, go ahead and work on the homework for 10.3.